Righty-ho, mad scientist, and welcome once again to the Mad Science Lab. We are so glad you're here. Now, today, well, it's kind of funny because Jeremy and the boys were doing a little bit of cleaning and they came across all these beads. And every time they'd pick them up, they'd drop right back down again. And when they dropped down, it just kept making a bigger and bigger and bigger mess. Okay, so they were asking me, why does that happen? Well, I said, well, the reason they're just sitting there like that is because of something that we call inertia. And the reason it moves is because of something we call inertia. Oh, there's that word right there. Inertia. Now, what does that mean? Well, simply stated, it means that something at rest tends to stay at rest. Something in motion tends to stay in motion until it's acted on by another force. That's pretty difficult. I tell you what, let's take a look at what our friends from Nakomi have to say. Okay, so that's pretty cool, but that's just a cartoon. Okay, so what can we do to show inertia in our lives? I am so glad you asked. Here you go. I made myself a hat. Now, I know you're thinking you always wear a hat. I made myself a different hat. I like to call it my inertia hat. And here it is. Pretty cool, huh? Yeah, there you go. So I put it right here. Now, one thing you're going to notice is how I made it. It's an old-fashioned wire coat hanger. I cut it apart, and then I put a tennis ball on each end. Now, what in the world did I do that for? I am so glad you asked. Watch this. If I move my head, I've got the tennis ball here, I've got the tennis ball here. And watch what happens. I move my head, move it back, move my head, move it back. And the tennis ball didn't really move until that last time. But watch this. I'm going to put it back on my head. And this is so cool. I'm going to keep my head perfectly still. I am going to spin that ball around. And it just keeps going round and round and round. Do you know why? Why? Well, first of all, to make me really, really dizzy because I keep looking at that ball coming around. But the main reason it did that is because I pushed it. Force. I pushed it. Action. Reaction, the tennis ball kept going around and around in circles. That's inertia in action. Now watch this. As it sits perfectly still, inertia in action, not moving anywhere. Watch again. Didn't go anywhere. Didn't really go anywhere. See, it didn't really move even though my head moved because there needed to be an action on the tennis ball. And there, it's going to fall. There we go. And now I can spin it around again. Now here's the thing. The tennis ball only acts as I make it act, or it only reacts. And I tipped my head back so the whole thing fell off. Again, gravity causing inertia to work. It was sitting there until it fell off my hat, fell to the ground because gravity was that force acting on it to pull it down to the ground. Inertia in action. Pretty cool, huh? Now that was pretty cool, but it was really, let's be honest, it was just an old coat hanger with a couple of tennis balls hanging on the end. Let's see something that's going to be really fun. Now, I know you've probably seen this on a movie or on a TV show. I like to call this the tablecloth trick. Now remember, an object at motion tends to stay in motion. An object at rest tends to stay in rest. I put together a kit here, and in this kit, I have what I'm going to call a tablecloth, okay? And I am going to lay this tablecloth out, as if we're getting ready for a fancy dinner, or at least some drinks. Okay, put it right here. Now somebody said I could use a cup of water, and somebody else said I should use my coffee, and I like my coffee, so I think I can do it. So I'm going to take my coffee, and put it right here. Okay, so I'm going to take my coffee, put it right there, and I want you to count to 3 and imagine that it will work, okay? 1, 2, 3. Ah, dang it. Well, that didn't work. But now that we've got everything cleaned up, I tell you what, we're going to try it again. I got a fresh cup of coffee. I spread out my tablecloth again. I got everything cleaned up. Now we're going to try it again. Remember what happened when I pulled the tablecloth. It went like that. Okay, don't laugh at me. But if I do it this time, watch what happens. Are you ready? 1, 2, 3. It worked that time. Do you know why?
Why?
What was the difference between this and this? I'm glad you asked. An object at rest tends to stay at rest. But here's something else that we have to think about. The mass, or how much there is, how much it weighs, how heavy and centered everything in this object is, makes a big difference. A while ago, I had just a little bit of cup of coffee. Now I've got a whole bunch. And that makes it more solid, and therefore it makes it want to stay there. Let's look at it again. This is the bad one, and this is the good one. And it's all because we changed the mass. So, object at rest tends to stay at rest. Object in motion tends to stay in motion. The mass of the object has a direct correlation, or it makes a difference to how that object acts towards inertia. Bet you didn't know that, but it's pretty cool, huh?